Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my channel yet, kindly subscribe. Also click on bell icon to receive latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 52, which is called as Pilot Assisted Sonalite Control of DC Valves. For large capacity pneumatic and hydraulic valves, the operating force to actuate the spool of the valve will be quite large. The actuating force exerted either manually or by Sonalite for direct operation of the valve may not be sufficient. In such cases, two-stage process called pilot operation is used. The figure shows the principle of pilot operation of a 4 by 2 direction control valve. The main valve is used to operate a ram using a cylinder. Actuation of this valve requires large force of direct operation. Hence, another smaller valve called pilot valve, which is also a spring return and solenoid valve actuated, is added to the main valve. This pilot valve is actuated by energizing the sonalite, and the high pressure air enters the pilot port of the main valve and actuates the main valve, thus connecting the ports P and B as well as A to R and extends to the cylinder. When the sonalite is de-energized, the pilot valve returns to its normal position due to spring. The main valve returned to its normal position, that is, connecting the ports P to A as well as B to T due to spring action. Now, high pressure air flow through P to A on the rod end side of the cylinder and retracts the cylinder. At the same time, air on the cap end side sent to the atmosphere through the port or via B of the main valve. Instead of making use of two separate valves for a pilot operation, a pilot or main valve assembly as a single unit are made as shown in the figure on the right hand side. When the sonalite S is energized, it operates a pilot valve and a line pressure acts on the surface of the control valve and depresses it, thereby blocking the port R, and at the same time port A is cleared and connected to port P. When the sonalite is de-energized, the pilot valve blocks the passage and the control valve opens the port R and closes the port P. Thus, the ports A and R are connected for the exhaust of the air. Then coming to control of circuitry for cylinders. Pneumatic cylinders can be controlled in various ways using different electrical elements such as limit switches, relays in various configurations in the form of a circuit. Now the figure shows the four possible switching function actuate double acting cylinder using a 4 by 2 solenoid spring return direction control valve. The possible switching functions energize and de-energize the sonalite of the valves as shown in these figures on the right hand side of the slide. The following symbols represents the different electrical elements in the circuit like switch, sonalite, relay and sonalite as well as limit switch you can observe. And these can be done with three different methods. We are going to discuss each and everything one by one. Now, the switch S, when actuated manually, energizes the coil C, that is nothing but the sonalite, which makes the cylinder to extend. When the switch is released, it breaks contact, de-energizes the coil C. The valve returns to its normal position due to spring. High pressure air flows to the rod end side and retracts the cylinder. Coming to method 2, in this case, relay is made used to carry the signal to the sonalite C. The remaining action, as in case of method 1, you can see the figure A in the next portion over here. Then method 3, in case of cylinder has to remain the extended position even though switch is released, then the circuit is as shown. The figure B may be used. If the cylinder has to retract after the extension, then the switch S2 can be replaced by a limit switch LS2 located at the end of the stroke. Similarly, for continuous reciprocation of the piston, that is, continuous extension as well as retraction, two limit switches LS1 and LS2 can be located at the end of extension and retraction strokes. Then control of single acting spring return cylinder we are going to discuss. The figure shows a simple electro-pneumatic circuitry to control the actuation of cylinder acting single acting cylinder. A 3 by 2 Sonalite actuated spring return direction control valve is used. The Sonalite is energized by means of a momentary manual switch. Yes, as the switch is released by the spring of the valve returns the valve to its normal position, which in turn retracts the cylinder. And the control of double acting cylinder. Now, the control of double acting cylinder is as shown on the right hand portion of the slide. A figure shows the circuit diagram of an electro-pneumatic control of a double acting cylinder using a 4 by 2 Sonalite actuated spring return cylinder. Here also the Sonalite is energized using a momentary manual switch ES which actuates the valve and hence extends the cylinder. As the switch is released, the Sonalite is de-energized, the valve returns to its normal position, thereby retracting the cylinder. Generally, the main source of supply will be alternating current whose voltage is reduced, rectified into a DC supply which is then input to the Sonalite. Let us, we have come to an end of the fifth module also, and these are some of the assignment questions for you guys for the entire fifth module. If you could able to answer for all these questions based on the previous videos what you have watched, so that you can able to clear the complete module. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tavardhan, and all the best for your examinations. Bye bye.